Hello, we want to talk about the hint to our homework problem, number 17 and number 18. Number 17 is that we solve the, suppose U is the solution to the nonlinear Schrodinger equation. IU sub t plus the process U equal to f of absolute value U squared times U in Rn, and we assume U is smooth and decays rapidly along with its derivatives as x goes to infinity, and we want to derive the following three identities, namely conservation of mass, conservation of energy, and conservation of momentum, where U bar is the complex conjugate of U. Okay, so we take the we take derivative of the first. So proof is very simple. You just keep in mind that IU sub t plus the process U is f of absolute value U squared times U, and its complex conjugate. If I take the complex conjugate of the equation, it becomes minus IU bar t plus the process U bar equal to f of absolute U squared times U bar. So when I take derivative on t with respect to t of the U squared dx, integral U squared dx, write U squared, absolute U squared as U times U bar. Then you write it out, and then substitute the equation into this expression, and you are going to after some computation, you will get a complete divergence. Okay, yeah, after some computation, you get the last line is a divergence, right? So you keep doing computation, you get integral Rn, 1 over I times integral Rn, divergence of minus gradient U times U bar, and plus gradient U times gradient U bar, plus gradient U times gradient U bar, minus gradient U times gradient U bar. And note that the second term and the third term can be cancelled, and therefore you get a complete divergence. And then you use divergence theory, you can show that this integral is 0. So the first identity is proved. d dt of integral U squared dx is equal to 0. Okay. All right. Now to prove the next identity. Okay. Now to prove the next identity, again, what you do is that you take the equation IU sub t plus gradient U equal to f of absolute value U squared U times U. Then you multiply both sides with U bar sub t. Okay. And then you take integration. Then you write it out. And keep in mind, you also have another equation from the complex conjugate. So you have minus IU bar t times U sub t, and so on. Okay. So when you add these two equations up, note that the first term of the first equation and the second term of the first equation, they cancel out. So you get the process of U times U bar of t plus the process of U bar times ut equal to f of absolute U squared times U bar t plus U bar ut. And then you write this out, use identity. Okay, use actually all these identity, just write it out, try to get it into the divergence form, and so eventually you get the process of, you get this equation, the process U, let me turn this the other way, it's easier for you to see. You get this equation. Okay, so you get the process, divergence of gradient of U times U bar t plus gradient U bar times ut, and therefore this portion, as you can see, it becomes 0 because of the divergence theory. Okay, so this is all just writing out and use identity. That's all. Okay, and then C part, then the third part is to do the conservation of momentum. Conservation of momentum, you take derivative of this integral. Okay, and then again, you just keep in mind we have two equations for nonlinear Schrodinger equation. One is that equation itself, and the other one is complex conjugate. So you keep writing on. So you use it, use the equation, and use the identity. Then eventually you write up. You just keep writing it. Okay. Yeah, just use the vector analysis really to write it up. So eventually you get into again I complete. So after some computations, some density computation, but it can be done. So you just keep writing on it, computing it, and you see at the very end you get divergence of something, so it becomes 0. Okay. Keep in mind that this d is really the gradient. Okay. All right. All right. Number 18, also the same thing. They want you to compute. They want you to find they want you to derive one identity, which is the second derivative of t of the integral of x squared times u squared. They want you to derive this identity equal to a times integral rn du squared plus 4n, so on. Okay, 4n